It's got to be fun. We're in summer school. Come on. If you don't like it, you don't have to be here. Okay, here we go. F of g of x. We're taking g of x. We're making the function g of x the input into f. G of x is defined as 1 over x. So we're taking 1 over x, and we're putting it wherever the x is in f. There's only one here. So f of g of x, one more, here we go, becomes 2 over 1 over x plus 3. There's 100 different ways we can take this one from here, but you should never leave it like this. Right? We're going to actually combine those that denominator, those two fractions, and we're going to do a little presto changeover with this. So we have 1 over x plus 3. If we want to simplify this as much as we possibly can, we're going to have to combine these two numbers. We just did something like this before. If you want to combine something that's not a fraction or something that is a fraction with something that isn't, make it a fraction. Now my advice, and this is going to be big when you get into calculus, believe me, go off into the margin and do margin work. If you try to keep everything in one, like if a lot of people like to work like down the page. If you try to keep everything down the page in a calculus class, you're gonna tie yourself into knots. So you know that we're going to have to simplify this. Go off into a margin, go off to the side somewhere, and do that side work so that you don't have to keep writing this 2 over blah, 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 blah. That's just my advice. Take it or leave it. So if we have 1 over x plus 3 over 1, and we want to combine these, we need that common denominator. And the fastest way to get a common denominator is to multiply the denominators. If I multiply x times 1, the denominator is x, right? So we have 1 over x plus, this is going to be 3x over x. Right? Questions? Now when I combine those into one fraction, you're going to think, well, that's not really that simple. But it's better to have one fraction than two terms. Okay? Not always. I shouldn't always say that, but it's not always better, but in certain instances. In this one too. So what we have, we're going to bring this back in now. So we have 2 over 1 plus 3x over x. Now you're going to also be confronted many times with fractions within fractions, right? And I'm just going to go off to the side here again as a teaching point. So what we have here is a situation where our fraction has, let's not do variables, let's just do values. Just as an example off here to the side. If you had 3 divided by 1/2, right? If you took 3 and you broke it, if you had 3 apples, whatever, and you broke them each into halves, how many halves would you have? You'd have 6, right? You'd have 3 wholes that you break into halves. That would give you 6 halves, right? Why? Because this is 3 divided by 1/2, and when you divide by a fraction, what are you really doing? Multiplying by the reciprocal. So this is really 3 times 2 over 1, which is 6. So what's the shortcut? The shortcut is when you have a fraction, all right, let's go back to here. When you have a fraction with a fraction in the denominator, to get your answer, multiply the denominator times the top. See how that works? Mm-hmm. Take the 2, multiply it times 3, 2 times 3 is 6. Leave the 1 on the bottom, it's 6 over 1, which is 6. Well, you can use that same idea here. I have a fraction with the fraction in the denominator. I can take the denominator and multiply it times the top. So we have 2x over 1 plus 3x. Every program, every textbook, everything you're going to see from here on out, that's going to be the answer that they want to see. Okay, so we're going to do a ton of stuff with nested rational expressions, which is what this is, fractions within fractions. Right? This is going to come up a lot more too. So I just want to show you that real quick. All right, cut.